All right, in this video, we are going to look at dividing rational expressions. And the process is factor everything you can, and then you're going to switch it to a multiplication problem. So leave the first fraction alone and flip the second to its reciprocal, and then you can multiply and then simplify. So it's equivalent to a multiplication problem once you make that switch. So let's talk about dividing fractions when you first learned how to do that. So here's what happened. If you had 1/4 divided by 1/2, we don't often talk about this, but it is possible to divide fractions across the top and across the bottom. 1/4 divided by 1/2. 1 divided by 1 is 1. 4 divided by 2 is 2. So 1/4 divided by 1/2 is 1/2. Okay? But what happened was when you got to problems like this, 1/4 divided by 1/3. 1 divided by 1 is 1. 4 divided by 3 is an improper fraction. Not going to be easy to work with. So the trick was you can change this 1/4 times 3 over 1, and that would be 3/4. Okay, because what I didn't talk about up here is 1/4 divided by 1/2 is the same as 1/4 times its reciprocal of 2 over 1, 2/4, which is 1/2. So that trick of leaving the first one alone and then dividing it by its reciprocal is how we learned, or the process we learned to divide fractions. And it seems kind of like, well, why can you do that? The way that I make sense of it is with 1/2. So think about this. If you have 8 pizzas and you divide them into halves, think about that. 8 wholes divided into halves. How many pieces of pizza in this case are you going to have? Well, you're going to have 16, which is the same as taking 8 times 2. Okay? I think it's easier to kind of conceptualize why this works when we're thinking about taking something and dividing it by 1/2, or taking a whole and dividing it by 1/2 or another fraction. So that's a process we're going to take. So let's look at a typical problem you could see. Okay, so here we have this rational expression, and you should pause the video and factor everything that you can, and then when you're done with that, press play, and we'll continue to go through it. All right, there's a lot of factoring we can do on this one. So in the top, 2x plus 14, we can factor out a 2. And what we have left is x plus 7. This pen is kind of wonky right now. I don't know if I'm going to be able to write much better than that, but let me try. Okay, so 2, and then we have x plus 7. Distributive property in reverse. In the bottom, we have x minus 3. Okay, and then divided by this one, when you factor this, it is x plus 7 times the quantity x plus 2. And then in the denominator here, we have a couple of things we can do. The first thing I would do, well, actually, yeah, the first thing I would do is I would factor out a 4. They have a 4 in common. So then we have 4 and then times the quantity x squared minus 9. 4x squared minus 36. But then you can factor this into a difference of squares where we have x plus 3, x minus 3. Again, if difference of squares is confusing to you still, there's a great video on Khan. I have it linked in the video resources, so check that out. Okay, and then the next thing we're going to do is we are going to keep the first fraction, or leave the first fraction alone. This pen, it's not good. Okay, and then we're going to switch it to multiplication of the reciprocal. So we're just flipping this fraction top and bottom. So we have 4 and then x plus 3 times the quantity x minus 3 over, what do we have up there? X plus 7 times the quantity x plus 2. Okay? And then you're going to multiply across the top and multiply across the bottom to get your final answer. So what we have is I'm going to multiply the 2 and the 4 up top and get 8. So those two constant terms together. And then what do I have? I have an x plus 7 that I'm multiplying. Whoops. I have an x plus 3 that I'm multiplying. And I have an x minus 3 that I'm multiplying. So all of these things together in the top that I'm multiplying, and then divide that by, in the bottom I have an x minus 3. And then I have an x plus 7, and I have an x plus 2. And then you look for things that you can cancel. So x plus 7 divided by x plus 7, boom, gone. X minus 3 divided by x minus 3 is 1, so that is also gone. So what I have left up, and that's all that'll cancel, so I have an 8 and then x plus 3 divided by x plus 2. You don't need to leave the x plus 2 in parentheses. You can. It's not wrong. But that would be your simplified answer. Okay? Now, if you wanted to cancel stuff a little bit earlier on, that is also an option. So I'm looking back at this fraction right here. And I like to put this in parentheses, you know, if I'm going to look at canceling, because I'm like, okay, this is a whole factor together. So this divided by this is 1, so they cancel. This divided by this is 1, so they cancel. And then I have 2 times 4, which is 8, x plus 3 up top, divided by x plus 2. I do not distribute the top. I leave it alone because then it's easy for anyone to see that it's factored, nothing else cancels, and the problem is done.